recommendation is to follow a fairly standard approach to exploring an hyperspectral imaging dataset. We will begin with relatively simple steps, gradually moving forward more advanced unsupervised machine learning techniques, as we only have spectral data available in the datasets I will upload. We naturally begin by uploading the datasets named data.mat. This is a MATLAB file, which ChatGPT will use in the next section. In fact, this file is transferred from my Google Drive to OpenAI servers. And for sure, it is the only step that will be performed manually in this process, as this functionality is not yet supported verbally by ChatGPT in its current version. So first, let's upload the dataset and just say that it is an hyperspectral one, and that's it. As you can see, ChatGPT has discovered that it was a MATLAB file, and it has the right description. This is effectively a 50 per 50 per 2048, 50 pixel per 50 pixel, and 2048 wavelengths. And for sure, in order to do that, ChatGPT automatically and without indicating it that it has to use something particular, ChatGPT has used a Python code, and this Python code, for example, is written like that. So now let's have a conversation with ChatGPT for data analysis. Show me the global integration image of this dataset with a color bar and a plasma color map.
The global integration image of the dataset is displayed using the plasma color map and includes a color bar. Let me know if you need further adjustments. You can check out the images in our conversation history.
Generate a figure with the mean spectrum of the dataset. Then apply peak picking on it in order to highlight the 10 most important peaks and show their location, their position, with a red tick and associated wavelengths. The spectrum must be in blue.
The figure shows the mean spectrum of the dataset, with the 10 most important peaks highlighted using red ticks and their associated wavelengths labeled. Let me know if you need further details or modifications. You can check out the images in our conversation history.
Generate an integration image for each wavelength you have just provided, considering the plasma color map, and add a color bar for each figure.
The integration images for each of the 10 most important wavelengths are now displayed with the plasma color map, including color bars for each figure. Let me know if further analysis is required. You can check out the images in our conversation history.
Okay, now let's go to something more difficult with some chemometrics exploration. I would like you to apply a PCA considering 5 principal components and then show scarce images with explained variants and corresponding loadings.
The PCA analysis has been applied, showing the score images for the 5 principal components, along with the explained variants for each and their corresponding loadings. Let me know if you'd like any additional steps or refinements. You can check out the images in our conversation history.
Okay, let's go now to another unsupervised method in the Chemometrics toolbox. I would like you to calculate now a k-means clustering considering 5 clusters and show the clustering map with a qualitative color map and the spectra of the centroids in a second figure.
The k-means clustering map with 5 clusters and the spectra of the centroids are displayed. Let me know if you'd like further analysis or adjustment. You can check out the images in our conversation history.
Okay, now let's count the number of pixels contained in each cluster and calculate the associated percentages, then represent these two results in a pie chart.
The pie chart represents the number of pixels contained in each cluster, along with the associated percentages. Let me know if you need further details or additional modifications. You can check out the images in our conversation history.
Can you also add the number of pixels for each cluster in the same pie chart?
The pie chart now includes both the percentages and the number of pixels for each cluster. Let me know if you'd like to explore further. You can check out the images in our conversation history.
Okay, now let's go to the last unsupervised method I would like you to do. Let's apply a non-negative matrix factorization on the datasets. In the first figure, represent the corresponding scores images with a color bar and the associated factors in the second one.
The non-negative matrix factorization, NMF, has been applied. The first figure displays the score images with color bars, and the second shows the associated factors. Let me know if you'd like further analysis or modifications. You can check out the images in our conversation history.